Hello YouTube, Mad Scientist 72 here. In 1952, a graduate student at the University of Chicago, Stanley Miller, and his mentor Harold Urey conducted a groundbreaking experiment in the field of prebiotic chemistry. What they were trying to do was simulate the conditions on the primordial earth. And so what they did in this experiment was they mixed a mixture of gases, methane, ammonia, and hydrogen. They introduced these gases into their apparatus, and also connected to their apparatus was a boiling flask which contained water which they boiled, which was meant to simulate the primordial ocean. Also, to serve as a catalyst, they introduced an electric spark, actually a 60,000 volt electric spark, through the mixture of gases and water vapor. And they conducted this experiment over the course of a week, and at the end of the week, the clear, colorless water that they started with had turned a murky brown color. It was filled with many organic compounds, among which were amino acids, one of the key constituents which are the building blocks of life. And this was a groundbreaking experiment which actually launched the field of prebiotic chemistry. Now, I had intended to replicate this experiment today. However, there was a problem and I couldn't get past it in time. But anyway, as you can see, I have the apparatus set up here. And what I was intending to do was to pass nitrogen, the cylinder in the back there, and carbon dioxide through the apparatus for about 10 minutes to purge all of the air from the apparatus, so that when we introduce our methane and hydrogen, nothing will ignite. And so basically this is the Miller-Urey apparatus. Well, this is my version of it. And I have here the methane, which I intended to use. And also the hydrogen. Okay, and what I did was with the ammonia, since ammonia is a very toxic gas, it's extremely alkaline. It's sort of like the gaseous version of lye, if you will. And so ammonia gas is extremely dangerous to work with directly. So rather than possibly exposing myself directly to the ammonia gas, I decided instead to simply add the requisite amount of ammonia solution, which would produce the amount of ammonia gas required for the reaction. And since ammonia is so toxic, over here I have this bowl filled with water, and all of the air would be purged out from the apparatus and bubble through this bowl to serve as kind of an airlock, and so that no air could get it back in. Once all the oxygen was purged, you wouldn't have any air coming back in and possibly igniting the gases. And also, since ammonia is so toxic, I have this looks like ordinary water. However, there is a small amount of hydrochloric acid mixed with the water, and what would happen is the ammonia gas would bubble through this liquid. It would react with the hydrochloric acid, because ammonia is a base, and you would produce ammonium chloride. And so this way we wouldn't have any stray ammonia vapors traveling through the air. Okay, and lastly, and this was the issue that I had the problem with, and this is the reason why I couldn't perform this experiment today. This device is called a spark gap generator. Now, it's hooked up to electricity, and the input voltage is around 6 volts. And the output voltage, which would create a spark between these two electrodes, is around 40,000 volts. So basically this has a step-up transformer inside which converts 6 volts into 40,000. And basically, let me show you how that works. I have my remote control here. Let me separate these. Okay, so I'll fire up the electrode. And as you can see, we have an intermittent spark of around 40,000 volts produced by this device. Now, the problem here is that although 40,000 volts is within the required range that you would want, once you start to heat the water and you create an atmosphere of 100% humidity plus high heat inside this apparatus, it reduces the amount of charge buildup between the two electrodes. And so you don't have the spark jumping the gap like you do here. This, obviously, in this room is not, it's room temperature and moderate humidity. But when you place it in here, you get high humidity and high temperature, which greatly reduces the amount of spark that's produced by this device. And so that was the major problem in trying to do this experiment today. I couldn't get this spark gap igniter to produce the required spark that I was looking for. But I will try it again, and I'm going to, I think that the solution is to increase the number of amps, because these wires are very small gauge, 20 or 22 gauge, and that tells me that there's not a lot of amperage running through there, and that probably, if you increase the amps, that would probably greatly enhance the spark that jumps across this gap. And so that's what I intend to do in the near future. I will try to come up with another way, another actual device to try to create that spark. And so stay tuned, and we will see what we can do in the future. And thanks for watching.